Good day, everyone. We are the Group 6, and we're here to present metal joining process. But before we start our discussion, let us welcome our researchers. Let's meet the team.
Hi everyone, I am Javier Michael M., the researcher of the group.
Hi, I'm Aramel Llanto, and I'm also the researcher of the group.
Hello everyone, I am Makalala John Lloyd R. and I'm the editor and researcher of the group.
Glassy Marasigan, researcher of the group. Hi, everyone. I'm Kyle M. Mendoza. I am the editor and researcher of the group. Let's begin. What is metal joining process? Metal joining process is a technique used to connect or fuse separate pieces of metal together. It is its primary purpose is to create a strong and reliable bond between metal components, enabling them to function as a unified structure. In addition, welding, brazing, soldering, and adhesive bonding of materials are all examples of metal joining. This process is crucial in various industries, including manufacturing, construction, automotive, aerospace, and more.
Types of metal joining process. First, we have welding. So, what is welding? So, welding is a metal joining procedure that involves the joining of two or more pieces that have polish at their contacting surfaces as a result of an inappropriate application of heat or pressure. Welding is sometimes done solely by applying heat, with no pressure applied. In other cases, both heat and pressure are applied, and in other cases, only pressure is applied with no external heat. So, in welding, we have its advantages and disadvantages. So, here are the advantages of welding. First, welding provides a permanent joint. Second, welded joint can be stronger than the parent materials. If a proper filler metal is used that has that parent base material and if defectless welding is done. So the third one, it is the economical way to join components in terms of material usage and fabrication cost. Other methods of assembly require, for example, drilling of holes and usage of rivets or bolts which will produce a heavier structure. Now, let's proceed to the disadvantages of welding. First, on the list, labor costs are more since manual welding is done mostly. Second, dangerous to use because of presence of high heat and pressure. The third one, disassembly is not possible as welding procedures produces rather strong joints. Some of the welding defects cannot be identified, which will reduce the strength. So we have three types of welding: diffusion welding, thermic welding, and solid state welding. So next slide. Fusion welding. Fusion welding. In fusion welding processes, heat is applied to melt base metals. In many fusion welding processes, a filler metal is added to the molten pool during welding to facilitate the process and provide strength to the welded joint. Heat is used in the fusion welding techniques to melt the base metals. A filler metal is injected to the molten pool during welding in several fusion welding methods to assist the process and provide strength to the welded junction. So We are we have five types of fusion welding. First one, arc welding, resistance welding, oxy-fuel gas welding, electron beam welding, and lastly, laser welding.
So, what is arc welding? Arc welding is a fusion welding procedure in which metals are melted and joined using the heat energy created by the arc between the work and the electrode. And when the electrode makes contact with the work and then quickly separate to maintain the distance, an electric arc is formed. Also, an arc welding is an electric arc that generated when the electrode contacts the work and then quickly separated to maintain the gap and the temperature of 5,500 degrees Celsius is generated by this arc. And in addition, this temperature is sufficient to melt most of the metals and the molten metal consisting of base metal and filler solidifies in the weld region. In order to have seam weld, the power source move along the weld line. Next. So, resistance welding. Resistance welding, sometimes called electric resistance welding or ERW. This is a process by which metals can be joined together by applying pressure and conducting a strong electric current through the metal combination to heat up the welding joint and melt the metals, forging them together. So, resistance welding is a fusion welding process that uses a combined effect of heat and pressure to accomplish joining. This heat is generated by electrical resistance to current flow at the location to be welded, and also weld nuggets in generated by this process. And resistance welding uses no shielding gases, flux or filler metals, electrodes that conduct electrical power to the process are non-consumable. And next, so oxy-fuel gas welding, and also this is commonly referred to as gas welding. This is a process which relies on combustion of oxygen and acetylene when mixed together in correct proportion within hand-held torch or blowpipe, and a relatively hot flame is produced with a temperature of about 3,500 degrees. So in this case, welding is performed by a flame formed by the combustion of oxygen and acetylene, like what I said earlier. And the torch flame comes from a and the flame comes from a torch. Also, so what is acetylene? So acetylene is a famous fuel because it is capable of generating a temperature of 3,500 degrees. And this welding or gas welding, oxy-fuel gas welding, has a problems and advantages. So the problem and advantages is the combination of acetylene and oxygen is highly flammable and hence hazardous to environment. Then next is it is unstable at pressure much above 1 atmosphere. Then it is mandatory for the welders to wear gloves, goggles, or we call this PPE, um,
Protective.
personal protective equipment, to prevent the measures. Then the advantages is the equipment is relatively cheap and portable. So it is used as an economical, versatile process that is well suited for low quality production and repair jobs. Next, electron beam welding. In electron beam welding is this welding is a fusion welding process whereby electrons are generated by an electron gun and accelerated to high speed using electrical fields. Then the high speed stream of electron is tightly focused using magnetic field and applied to the material to be joined. So in this process, welding is carried out by highly focused, highly intensity electrons beam bombarding against the workpiece. And also, this welding has disadvantages and have a three categories. So the disadvantages of this electron beam welding is high equipment costs, precise joint preparation needed, and shielding of humans from X-ray. Then the three categories of this welding is high vacuum welding, in which welding is carried out in the same vacuum as beam generation. Then second is medium vacuum welding, in which the operation is performed in a separate chamber when only a partial vacuum is achieved. Then the last is non-vacuum welding, in which welding is accomplished at or near atmosphere pressure. Next. Then the last type is the laser welding. Laser welding is a fusion welding procedure that uses the heat energy of a highly concentrated, coherent light beam focused on the joint to be welded to achieve joining um, olefins. So this laser beam welding have advantages and disadvantages. But first, the advantages is no requirement of vacuum chamber and no X-ray are emitted. Laser beams can be focused and directed by optical lenses and mirror. Then the disadvantages is um, only small parts are joined by laser beam welding because of the highly concentrated energy in a small area of the laser beam. Next. Thermite welding. So, what is thermite welding? Thermite welding is a method that employs heat from an exothermic reaction to generate metal coalescing, and the word taken from the term thermite or thermite, which refers to a reaction between metal oxide and reducing agents, and the thermite mixture is made of a metal oxide with low temperature of formation and metallic reducing agents with high heat of formation when oxidized, and the excess temperature of reaction product creation supply the energy source for forming the weld. So this is a mixture of aluminum powder and oxide that produces an exothermic reaction when ignited. Next. Solid state welding. So what is solid state welding? In solid state welding, materials are joined using either heat and pressure or pressure alone. The basic metals are not melted in order to form a metallurgical connection, and to metallurgical connection bind two similar or dissimilar metals, the metal must come into close proximity so that their atomic forces attract each other. And to allow atomic bonding, the two surfaces must be clean and devoid of oils, dirt, chemical, coating, gases, and so on. And the metallurgical bond is created with little or no melting of the base metals. And to metallurgical bond, two similar, like what I said earlier, or dissimilar metals, the two metals must be brought into intimate contact so that their atomic forces attract each other.
So next on the list of the types of metal joining process is brazing. So what is brazing? Brazing, it is a joining procedure in which a filler metal is melted and joined together. Capillary action distributes the fluid between the faying surfaces of the metal components being connected. Only the filler melts in brazing, not the base material. In brazing, the melt temperature or the liquidus of the filler metal is higher than 450 degrees Celsius, but lower than the melting point, which is the solidus of the base metals to be connected. In addition, brazing is a process that joins two or more metal surfaces by letting molten metal flow into the joint. The filler metal has a lower melting temperature than the parts to be joined to keep the workpieces from melting. So brazing has also advantages and disadvantages. Let's talk about the advantages. Brazing is a joining process that produces stronger, more reliable joints than welding. Can join the similar metals, which is impossible with welding. Not require as much as heat as welding, so it is less likely to distort the joint metals. Brazing can join fragile pieces of metal that would be difficult to weld. Joints are less likely to leak than welded joints. Now let's talk about the disadvantages of brazing. So, limited to certain metals. It is limited to certain metals. It requires clean surfaces. It is not suitable for large joints. It can cause distortion. And lastly, it requires special equipment. So, next on the list of the types of metal joining process is the soldering. Soldering is a procedure. Ano? Saan ka natapos? Hindi, yung ano, panibago dito na lang sa soldering.
Sa soldering na lang, ikakat ko na lang. Kasi ikaw na soldering.
Babasahin.
Soldering. Ngek, may ano ka, may background ka.
Cellphone lang kasi ako.
Ay, ilagay mo yung background natin para kahit pa paano may background. Size 10 and a half pa. Lagay yung background natin para may nakalagay ka.
Oo pare, kasi naka-portrait kung ano ka cellphone. Kaya na. Start.
Kaya na.
Tayo, babasahin ka lang.
Oo nga. Ayan, gagawin. Yun lang ang magagawa eh. Game.
Soldering. What is soldering? Soldering is a joining procedure similar to brazing in which a filler metal with a melting point, liquids less than 450 degrees Celsius, is melted and spread by capillary action between the fading surfaces of the metal components being joined. The base metal are not melted as in brazing, but the filler metal wets and mixes with the base metal to establish a metallurgical bond. Advantages. This can be operated at low temperature. Base metal does not melt. Any metals, non-metals can be joined by this process. This operation requires low power. Less time required to join. This can be easily operated. Disadvantages. Strength of joint is less. This is not useful when joint works under high temperature. It is not useful at long length weldings. Heavy metals can be welded by this operation.
there is a chance of toxic components at fluxes. For better understanding, we prepared a YouTube montage and YouTube video that will provide a more detailed explanation of the metal joining process.
What's going on, Juco?
Okay, so we're going to be looking at the last stage of all of the joining processes in the Edexcel GCSE RM syllabus. We've previously looked at temporary joining methods being ways to join materials and then take them apart without breaking the material. We've looked at permanent joining methods that are ways of connecting materials permanently forever. And you cannot take them apart without breaking the material. In that, we looked at wood joints. We're now going to look at the other side of permanent joining, which is metal joining. In our syllabus, there are 4 methods of permanent joining methods for metal that we need to know. There are soft soldering, brazing, and welding. All 3 of them are very closely linked, and we'll go through that in a minute. And the 4th joining method for metal will be rivets, and in rivets there are 2 types of rivets: snap rivets and pop rivets. So to start with, we'll look at soft soldering and go through brazing and welding to show similarities. Soft soldering, more commonly known as soldering, is when 2 pieces of metal are wanting to be joined together, and the way that happens is that solder, which is another type of metal with a very low melting point, is melted usually using a soldering iron or a heat implement. The solder is melted and it flows in between the join of the 2 pieces of metal wanting to be joined. If you have a look at the picture, you can see a good example of that is where the solder, the metal that has been melted and flowed in between the joints, is uniform around. There isn't a crack in it and there's no breaks in it. It's all the way around. And a bad example there is where there's limited solder. It's not uniform. There are cracks in between the join. It's very important that solder gets all the way around that join uniformly and it really glues it together. Because what will happen is that solder will then solidify, and as it solidifies, it will act like a glue holding it together. Solder is also very commonly used in circuit boards and electronics to fix the electronic components to the main circuit board, and it can be used to just quickly solder all of the components onto the circuit board. Many advantages for soft soldering is that it can be done very quickly at low heat, which means it's a very easy method of joining. It's used all the way through schools in electronics and systems classes. It's also used in a lot at university to create small electronics. We can also use it at home for quick maintenance of pipes, like in the example, and other kitchenware and plumbing that has gone wrong. So it's very quick, it's very easy because it can be done at low heats with minimal maintenance, and it's very available to be used in the home. Obviously, the disadvantages of that is that because it is done at low heat and it's quick and easy, invariably it means that it doesn't produce a very strong bond. It isn't a very strong joint. Therefore, it can only be used on small, non-load-bearing areas. Also, a bit of an issue is that surface oxides can build up on the surface of the joint, which means that you have to use a flux to prevent that build-up. And the flux needs to be rubbed on the joint to prevent the build-up of oxide because of the heat. If we then move on to the next stage of joining methods through heat, which is brazing. Now, brazing is like the big brother to soldering. It's very similar. Again, we use another piece of metal that we melt, which acts like a glue to join our two joining pieces of metal together. In this case, that is called the brazing rod, as you can see in the picture. And that brazing rod melts and joins those metal pieces together. The difference between this and soldering is that it happens at a higher temperature and therefore creates a much stronger joint than soldering. Therefore, we can use it on larger joints. We can use it for load-bearing systems, things that require much stronger, more durable joint. The other difference is that whereas in soldering we would use a heat iron or a soldering iron, which is just a piece of metal, a metal tool that gets very hot. In brazing we need to use an open flame, so we'll use a brazing torch, which will be an open flame that will heat the brazing rod to a temperature where it melts. As in soldering, an oxide, which is a layer of kind of rust or of degradation because of the effect that oxygen has with the heat and the metal, because that appears on the joint, we need to use a flux to stop that happening. Flux is just an application of a material that is rubbed over the joint to stop oxidation happening. Because of that, it's obviously a lot more time consuming because you have to prepare the surface. Also, because we have to do it with a much higher temperature, the disadvantage is that the only material we can use is mild steel, because mild steel is the only metal with a high enough melting point, or the only widely available metal with a high enough melting point to be able to use brazing. Rivets and pop rivets. The snap rivets on the bottom left, very simple. The sheet metal will have to have a hole drilled in it, and the snap rivet, both pieces are slotted through the holes, through the two pieces of material, and are pressed together, and that creates the joint. And because of the shape of the teeth on the snap rivet, they can't be then pulled apart. It becomes a permanent fixing. You can't pull them apart. Pop rivets are slightly more complicated. Now, a pop rivet comes as a component, a bit like a screw or a bit like a bolt, that you would place inside the holes between the two pieces of material. So your two pieces of material are placed together, the hole drilled through, the pop rivet would go in between. You would then need to use the rivet gun, like in the GIF that's on the screen. The rivet gun would hold the pop rivet, and as it's being squeezed, it will pull the interior rod up through the exterior piece, and as that is pulled upwards, as you can see in the picture, the part at the bottom of the pop rivet pushes the metal exterior outwards, creating two ends of a rivet holding in the pieces of material, and that is now permanent. The only way to get that out is to physically drill it out, so by ruining the material. So the interior of the rivet is pulled up, which squeezes out the exterior pieces of metal, tightening the two surfaces together, and creating a permanent joint. These are the only methods of permanently fixing metals together that you need to know for this course.
Welding defects and inspection. So, what is welding defects? Welding defects are imperfection or irregularities that occur in a welded joint which can compromise the integrity and strength of the weld. Proper inspection of welded joints is crucial to ensure that they meet the required standard and specification. Here are some common welding defects. Types of welding defects. Porosity. The presence of small voids in the weld metal, often referred to as porosity, occurs to the entrapment of gases during solidification process of the weld. These voids typically result from several factors, including the inclusion of atmospheric gases such as oxygen and nitrogen, the presence of sulfur in the weld metal, or contaminants on the surface of being joined. Porosity in a weld can compromise its integrity and strength, making it a critical concern in welding process. As it as it weakens the weld, it can lead to structural issues and or defects. It is essential to take preventive measures and ensure proper welding techniques to minimize the formation of these voids. And procedure high quality durable welds. Overlap. Overlap is also known as a cold lap. Occurs when the edges of the molten weld metal do not fuse properly with the base metal. Instead, they flow over the surface without creating a solid joint. Overlap result in a weak and unreliable welds as it lacks proper fusion between the materials. Burn through. Burn through happens when excessive heat and welding current cause the material to melt entirely through the joint, creating a hole. This defect can weaken the structure significantly and is generally considered as a severe welding flaw. Cracks. Cracks are fractures or separations in the weld metal or adjacent base metal. They can occur due to various factors including excessive thermal stress, rapid cooling, metallurgical inconsistencies, or inadequate fusion. Cracks pose a significant threat to the structural integrity of a weld and can lead to catas- catastrophic failure if not addressed. Methods of inspection. Visual inspection. Description. The most basic form of inspection where a trained inspector usually examines the weld for surface irregularities. Suitable for de- detecting surface defects like porosity, cracks, undercutting, and etc. Radiographic testing or RT. Description. Uses X-rays or gamma rays to create an image of the internal structure of the weld. It is suitable for detecting internal defects like porosity, lack of fusion, and cracks. Ultrasonic testing or UT. It is uses highly frequency sound waves to detect internal defects by analyzing the reflections. It is suitable for detecting internal defects like thickness measurements and some surface defects. Magnetic particle testing. It involves applying a magnetic field and iron particles to detect surface and near surface defects. It is suitable for detecting surface cracks and other surface irregularities. And the last one, eddy current testing. Uses electromagnetic induction to detect surface and near surface defect. It is suitable for detecting surface and near surface defects. Conductivity measurement. Choosing the appropriate inspection methods depends on factors like the type of welding process, materials, thickness, and the criticality of the joint. It's often recommended to use a combination of these methods for comprehensive inspection. Trained and certified inspectors play a crucial role in ensuring the quality of welded joints.
Thank you guys for listening. This is Group 6. Peace out.